Hi, my name is Dean Still, and I'm with Aprovecho Research Center. We just published a new book, and it's available at aprovecho.org. So please check it out. This will be a quick review. If stoves pollute in the lab, they will in the field. We estimate about 3 times more. The stoves that are available out there meeting in-field WHO standards are very rare, maybe almost non-existent. We are committed to doing R&D, to getting needed new stoves to market so that field studies show success in sales, protecting health, saving wood, and making cooks happy. Check out the book. We live in a brave new world. Will combustion that elevates CO2 that is not carbon neutral be prohibited? European countries are planning to ban 2035, as is California. Carbon neutral burning changes the energy ladder. Renewable biomass rises up and fossil fuels go down. But to be carbon neutral, renewable biomass has to be burned very, very cleanly, no smoke. So we can protect individual planetary health, but we need to do it with complete combustion of renewably grown biomass. To do that, we need to have great stoves. How do we do it? Well, at Opera, we do the lab first, and then we ask the cooks and manufacturers to really teach us how to make the stove. So in the lab, we learn how fire works, and then the cooks and the manufacturers and the whole team in the field teach us how to make the product. Usually it makes most sense to work with the manufacturer in the field who has an established market, and then we improve their stoves. Health. So these are all chapters in the book, so this is very fast. Indoor exposure can be reduced by using an airtight cook stove with a chimney that makes the least amount of smoke in a kitchen that has the most air exchanges per hour. Functional chimneys are what we use in the US, and we have horribly polluting stoves here, but the pollution goes outside and we don't breathe it in our houses. With clean outdoor air, doubling the air exchange rate halves the concentrations of PM and CO in the kitchen. There are not many stoves that will do that. So the air exchange rate is very, very effective in helping people breathe less smoke. Outdoor air in Tier 4 PM 2.5 stoves. An outside air emissions model was constructed by the EPA to estimate the air pollution in Oak Ridge, Oregon, and to see what would happen if they used better and worse stoves. The PM would be reduced from 40 micrograms per cubic meter to 13 if they used better stoves. Theoretically, the outdoor air concentration would only be increased from 13.1 to 13.3 in Oak Ridge, if the 1,000 homes also used an ISO Tier 4 PM 2.5 cooking stove. Why? Because the outside box is a heck of a lot bigger than the inside box. And the little amount of smoke that a Tier 4 stove puts into the air is nothing compared to the horrible heating stoves that they're using now. Check it out. All right, I don't have time to really go into this, but I always want to make sure that people look at the book, read the chapter on heat transfer. Baldwin in his graphs showed us how to get close to 45–50% thermal efficiency by using a skirt, and a skirt costs $1 or $2. So just like a chimney, which is a traditional solution to problems, the skirt is really super important on the list of effective ways to help people save fuel and breathe less smoke. Combustion. Well, I'm going to go, I hope that I've saved enough time to actually go into this. Combustion is, we know a lot less about how to make better combustion. Rockets and TLUDs share characteristics. The gas is released from the hot wood that flows into the fire above the fuel. Charcoal forms as the wood is burned. When the right amount of well-mixed gases and air flow only into the flame and reside there for a long enough period of time, almost complete combustion can occur. So it's not that hard to envision how complete combustion works. Basically, charcoal makes CO. The wood makes the PM. The minimal temperature in flame is 1000 C. The resonance time for tier 4 PM 2.5 and CO at 1000 C is about 0.15 seconds. So that's a new learning, and you can check out the chapter on combustion. Metering the fuel, making only the amount of gas that can be consumed in the flame, is accomplished in the rocket by burning the tips of the fuel, and in the TLUD by limiting the primary air. When we make too much gas, we see smoke. And so metering is something that has to probably come first when you're trying to make less smoke. Okay, metering, mixing are probably the two most important things. You need the high temperature, say 1000 C in the flame, but the resonance time seems to be fairly short, like surprisingly short. So anyway, check it out. It's in the book. Post-combustion. Well, we have used filtering of the smoke through home furnaces filters, but we also are exploring electrostatic precipitation. And thank you so much to the EPA, SBIR, for allowing us to spend the last 2 or 3 years looking into all these problems. With an ESP, factories are super clean burning, but post-combustion is something that we really should look into, as well as just trying to make the combustion clean. Even cars use catalytic converters, so I think it's going to be a combination that gets us to really clean. The Harris TLUD may be the best stove that I know. Cooks at Opero love it. It has a 3-to-1 turn down ratio. It has natural draft static mixers that are surprisingly effective in reducing smoke. It achieved an amazing 0.7 milligrams per minute PM 2.5 with pellets when tested at LBNL. There is a lot to love about Kirk Harris's stove, and you can learn a lot about modern TLUDs by looking at it. We worked with the Gates Lab and with SSM to create the jet flame. The jet flame is only bottom air. It blows fast jets of air up into the flame and creates high temperatures, creates good mixing, and now there's field projects happening in Malawi, in smaller ones in other countries, and so we hope that this new approach to clean burning is going to be helpful. Where are we at? Oh my gosh, look at that situation. Luckily, what we do, renewably harvested clean burning of biomass, looks like it's going to become more and more important in a carbon neutral world. We are getting too slowly closer to practical solutions, but we're going to make great progress now that the skies are blue. Check out aprovecho.org and the new book. Thank you.